let's talk about models. Models like linear regression. Weather models, which are in fact models sitting on top of models, which sit on top of differential equations, sitting on top of blah, blah, blah. Models like large language models. Heck, this is actually a flowchart. So this is a model of a model. And of course, this is something that's creating a lot of consternation in our industry right now. And models like this Athern model of an EMD SD40-2 from Milwaukee Road in 1972. Wait, Peter, that's not a model like we do. Heck yeah, it is. Models are an imitation of the real thing. And the models that we train every day, and the models that model railroaders play with, and the models that D&D people play their RPGs with are all the same damn thing. They're all classes of the same super type of models. You might not have ever thought that thought, but that's because we data scientists are a bit of a haughty bunch. I'm hungry. Brunch, bunch, whatever. Just a few years ago, we were the sexiest job of the 21st century. DJ Patel, keynote talk, plugging this. When you're a speaker, plugging the other speakers is a key skill. We're not the only people who get to play in the data sandbox anymore. Our industry is undergoing maturation. There are all sorts of other data jobs. See the other tracks at this conference. We are now playing with other model builders who are calling themselves decision scientists. We have storytellers, all the different analyst jobs. We have code builders in the form of MLEs, and as a horrible, horrible coder myself, I thank God every day that we have people who I can blame for coding problems. Work with me. These days, we have machines that can do a lot of the mechanistic stuff that we have drilled down for a decade and a half on very heavily as an industry. They can do these things for us. So what's left for us data scientists? When we get out ahead of ourselves, we have an AI winter. In the 60 years of our industry, and yes, we are a 60-year-old industry at this point. We think we're very young. We've been around a while. We've had 2 AI winters, and this boom that we are in right now is the biggest boom that our industry has ever been in. It's been long. It's been really, really good for all of us, and I don't think any of us want it to end because our paychecks depend on it. Complete aside, no, this wasn't a planned thing. I was talking to someone during the last break downstairs, and she told me the definition of prosperity is when the booms get so close together, you don't notice the winters. And I thought that was really profound, and I want to share that right now. Cool thought. We data scientists are quantitative thinkers. By the way, that last talk, very quantitative. This one, there will be 0 equations, and if I can get away with it, there will be very few with text, period. We can look at all sorts of things. We like to think in analogies. So let's go back to those model builders, those model railroaders, right? What were they doing when they were 60 years old? Where did their world go to? If we can take a look at where other people who have thought about the world as a simulacrum, and take a look at where they go, maybe we can see what's going on beyond the end of this timeline here. And why should you trust me in my ill-fitting code up here? Well, 1, I'm up here and you're not. Thank you, Chevy Chase. I thought it would be a good joke. 2, because I am a geographer and data scientist. I've been running DS teams for many years now in multiple companies. And 3, because I have been a model railroader my entire life. My dad is a model railroader. My brother is a model railroader. And God willing, I'll get my son to be a model railroader too. So I've been thinking about models pretty much my whole life in very, very different ways between when I am home in the basement and when I am at work at my desk, which actually for the last couple of years is the exact same place. Model railroading, when it was 60 years old, was a very similar place to DS today. So model railroading starts out in the 1880s with these things called carpet dribblers. They're copper and brass toys for kids and kid-like adults. You fill them with water, you put fire underneath, because in the 1880s, fire was an appropriate kid toy. And you let them run across the carpet. And they're called carpet dribblers. They dripped water and oil and set fire to carpets. Cool. Early 1900s, electricity comes into play, and we have electric trains. They are still for kids. They are a toy. And the early part of the 1900s being who they are all very white people, males in these pictures. I really tried hard to find a woman in one of them, and I could not do it. Sorry, I did try. People are playing with them still as toys. They take the track, it goes around the living room, it goes attached to some plywood. It's doing stuff. It's not the carpet dribbler that ran randomly and set fires to things, but it's still a toy. 60 years in, it's the mid-1940s, World War II has just ended. The GIs are coming home. They have basements for the first time in suburbia, and they're filling them with trains. It's the biggest hobby in the United States of America. It's something which people don't think about these days. And people want to go beyond just being toys. Kind of like data science going from good old-fashioned AI that barely works on to machine learning that works a lot better to AI, which is now eating the world, although I personally hate the phrase AI. One of the first people who thought about this was a guy named Frank Ellison. He says, we're going to stop being a toy trains and start being the art of model railroading. We're going to go beyond this. We're going to have your railroad, which is, in model railroading speak, the layout, the scenery, the track, all the stuff. In our world, we call that a model, by the way. We're going to make that be a stage. The trains are the actors on that stage. They run through it, and they're going to have jobs. They're not just going around in circles for no reason. They're going to have actual reasons. And he goes through this very elaborate analogy over multiple parts in his series, and his analogy is theater. I say the analogy this day should be data science, the things that we're doing. That layout is a model of the world. The trains that are on it are actors moving through it that are programmed in different ways. Of course, he's not using code. He's writing diagrams like this. So, walking away from the microphone, sorry. You can see here's his railroad as a block diagram. At the bottom, we have different trains. Those trains all have different jobs and names, the local passenger train, the manifest freight, the local switcher. They meet at different places along this at different points in the schedule. He's programming a diagram, a graph, if you will. The nodes are the stations and the sidings, and everybody's meeting up and following their instructions. You are an engineer. You're playing an engineer, just like you were in some D&D game or something like that. You're an engineer. You're a dispatcher. You're a yard master. You are running the passenger train. You are following rules, and you are running a railroad. This is a very different way of thinking about things. He's building a model. It's a physical model, but it's still a model. On the other end of these world of making model railroading more serious is John Allen. And he builds a railroad called the Gory and Defeated in Monterey, California. And he's friends with all sorts of folks from Walt Disney. So there's Imagineers who are working on this railroad. There's early folks coming in from Silicon Valley. Some Intel founders actually were involved with this at some point. And they're all building this railroad together. But the point is not to be realistic. It's to be this epic sort of world that's new, that didn't exist in the real world. You can walk into this, the scenery is floor to ceiling. It's all over the place. There's a train in here. Can you even see it? It's out there in the middle. It's besides the point. The point is the entire world that's built around this. The trains are doing not as sophisticated things as Frank Ellison. His world is whatever. We've got a railroad. That's besides the point. The trains, the things are doing things. Here, the environment is important. Okay. What the hell does this mean, Peter? You're showing me pretty pictures of trains. We're data scientists. Okay, let's bring it back to our world. Frank Ellison is very much so in the vein of folks who want to build simulacrums of the world, actor models, things like that. Whereas Frank Ellison, he wants to throw everything at you and let the machine figure out, you experience, pick the part that you want. That's like a large language model. What's going on here is they're thinking about rules-based systems versus creative-based systems. They want to come up with different ways of experiencing the world that don't exist, that are like the world, but a lot smaller than it. That's data science in a nutshell. So with that first section done, why I think this is a good analogy for data science and where we're going, let's go and take a look at some of the thoughts from model railroading at this period and take them back to data science and see how we can think about models differently, how we can apply those lessons to what we're doing today. So this one was hard to visualize because I resorted to text, and I never do that. The 10-foot rule is this idea if something looks good at 10 feet, it's probably good enough. We call this overfitting in our world. This idea of drilling down to something to a level of detail that's way beyond what you need. And this is also not just a problem in training models. I think this is an overall problem with data science as a whole. You read papers coming out of KDD or neural IPS, and a good third to a quarter, quarter to third of them are going to be, I've increased the accuracy on some benchmark model by, 2 decimal points. Big whoop. It's so what? What we need is things that solve big problems, not little problems. Anyway, I digress. The 10-foot rule. When we are in model railroading world, we talk about the prototype, the real thing. In data science, we talk about ground truth, or training data. This is training data for a model railroader. This is a real train, not a model. I wish I was that good. This is a specific engine that runs on Canadian National. It's an EMD GP38-2, and I don't know this. I actually had to ask my brother. He's much better at this than I am. I just say it's a train. Specific thing, it's got a special paint scheme, so it's the only one that has this paint scheme. Here's a model of that train. It's made by a company called Rapido. And Rapido is very, very drilled in on the details. So the paint is the exact same shade as the real thing. It has the paint scheme. It has the exact windshield wiper that particular model has, because apparently the one on the right is different than the one on the left. And people who buy these types of models care about those things. Here's another model of Unit 6401. It's got a wee bit less detail, but it's still clearly the same thing. Now, we do things in data science. We tend to try and focus in on the details. But this is just a way of showing us that it doesn't really matter to get that drilled in. You can go way farther out and still have the important stuff about something. It's a continuum. When we're building models, it's not just to, maximize accuracy or, recall a 10 or what have you. Our job in a world where there are lots of people playing in the data sandbox, data scientists are supposed to be the coordinators. We're not supposed to be the ones actually building the models. That's what decision scientists are for. We're not supposed to be the ones writing the code. That's what machine learning engineers are for. We're not telling ultimately the stories to the clients. That's what analysts are for. So what's left for us? Our job is to think about the data, to think about the models, the trains, to think about the data that goes into those models, the layouts, the things that are around them. Our job is to be the coordinators, to be closer to artists than to technicians. And I probably should have hit the button that shows data science when I said that. But even if you go all the way drill in on those high fidelity models from Rapido or companies like that, there's compromises that are being made. Our decisions as data scientists are to manage those compromises. Just like someone on Wall Street is a risk analyst. Their job is to think about all of the things that can go wrong, that impact things. We should be the folks who are thinking about all the things that go into data, not just, I happen to have a file and these are the things that are in it. Here are the correlates to the things that are in it. Here are all of the things that it could connect to. We need to become managers of data, because this model is not the real thing, ultimately. Somewhere it had to make a compromise. It's powered by an electric motor, not a 2,000 horsepower diesel engine. It's ultimately not really the real thing. It's a model. It's an imitation. All of our models are imitations. All of our models are compromised. We hear this phrase when we're learning first about models. And then we probably never think about it again. And that phrase is, all models are broken, but some are useful, right? Ultimately, all of our models are not really representing the real world. Our job is to become the compromise managers of those things. So in model railroading, there are lots of different scales. G scale, which is what I model, big, chunky trains. In fact, so big they won't fit in my house. They are in my garden. My brother, he models HO trains, a lot smaller, fit inside his basement. So does my dad. It's a common choice to pick a smaller thing because they have a smaller space. Part of that compromise management that we're going to have to be doing in the future as data scientists is to making the same choices that a model railroader would when they're picking their scale. Now, maybe you make your choice based off of your available space. My brother has a big basement, so he can put that HO train in it. But what if you have lots of space? And the thing is that what you really are interested in is the mechanics, right? Well, you can go big. This is called live steam. It's the biggest model railroading scale. This is a steam engine, right? It's got a fire inside. It's just like that carpet dribbler, hopefully not setting anyone on fire. That boiler is filled with water. There are fire tubes. Fire is going through those tubes. It's boiling the water. It's turning pistons. This is as close as you can get to the real thing. This is the highest fidelity model you can build, right? Well, you still have to have compromises. This is Train Mountain. It's the biggest private railroad, I believe, in the United States and possibly the world. And to have those big live steam models, it covers square miles. This is the model railroading equivalent of having a high-performance computing cluster. This is a supercomputer of trains. They're expensive. They're big. That is a compromise that someone had to choose to do. I want the big thing, not I have to fit it inside the space that I have available. If you don't make that compromise, you end up with something like this. This is the Cadby Railroad. It's, I believe, in Wales. And this is it. So the Reverend Teddy Boston, who built this, was able to get a real narrow gauge steam locomotive and a car, 2 cars. And this is the entire railroad. It extends about 5 feet on either side of this photo. He was not willing to compromise on size at all, so he had to compromise on his environment. In other words, it's always a compromise. Even if you think you aren't making a compromise in your data, by drilling down and having as many features as possible, you are also making a decision to eliminate all the things outside of it. There is no happy median. Everything that we do is in some way going to break from the real thing. This isn't an equation that can be solved, unfortunately. I know everything in data science is ultimately some kind of optimization problem, but this is one that there is no equation because it is a human problem. It is a problem of resources. It's a problem of the things that you have available in front of you. And it is ultimately a political problem because we all work for people and all of those people are telling us to get shit done faster. And you only have this many resources to do it with. Everything is a compromise. Most of our environments probably look less like this, because as far as I can tell, this is the only one in its kind in the world, and more like this. So this is Z-scale. This is the smallest practical model railroading scale. And with this, I could build a whole railroad in a briefcase. I wouldn't, but maybe somebody else would who wants to. Now you're talking a train that is 20 feet long in live steam, fits on your pinky finger. Now, that's a compromise that you have to choose. Compromise, I keep saying this. It's almost like it's the theme that I want you to walk out of here with. Crazy. Maybe your compromise goes in a different way. You love big modern trains that can be up to 2 miles long. Well, you have little tiny trains, but a big basement. And that means that I can now go with the length with higher fidelity than I can with the individual models. Again, we need to be thinking about the things that go into our models. If the trains are individual rows of data with features and the layouts are the models, then we need to be the people who are making the artistic choices of what goes into them. Like I said, these are optimization problems, but they're not solvable ones. That's why you need data scientists. This is a call to arms, that this is where our industry is going to be going. There's lots of things out there that are going to be replacing the drudgery. And if you replace the drudgery, you'll end up with the art. We have to rise to that. So let's take a look at one last thing. And again, I couldn't find a good photo, so we had to resort to text. I consider every text slide in a Peter Lenz presentation to be a failure. This is the Hatchby Loop. It's a very famous place in American railroading because it's one of the very few places where we have a spiral, a place where a train crosses over itself. So there's lots of people who want to model this. And here's somebody who did in N scale. Not quite as small as Z, but pretty dang small. And they've gone all out to recreate it. That house is really exactly right there. It's the same size as the real one. The train crosses it over itself. These are the right types of cars for the error. This is really realistic. But even then, compromises. For example, in reality, no fluorescent lighting on the ceiling, no hovering exit sign in the background. You can go really, really deep, but you can't go 100%. This is called prototype modeling. And this is actually mentally where a lot of data science is today. We take our data and we recreate it inside of a model. Jack Burgess is kind of the dean of this kind of thinking in the US. And he models not just a specific railroad, but a specific railroad on a specific day in a specific year. The Yosemite Valley Railroad near the end of its life. And this is his railroad on the one side, and on the other side is the exact same photo from real life. He's got the exact same cars as they existed. If there's a plank missing, he pulls that plank off. You can tell they're different because in this photo, you can see right on up the Merced Valley, up into Yosemite Valley. And on his, well, that ends because he has a wall there. You know, real life has walls that get in the way of your model railroad. You have to curve around them. I really like this particular one because that tall tree there on the hill is right where I lived when I worked for the National Park Service. At the other end of scale is complete creativity, freelancing. This is Roland Element. He made trains that have no basis in reality. They are made up. There's no tradition like this in data science. We have toy data. Our toy data sets are still based off of reality. But there's still a lesson that we can learn here by blending the two ideas. Prototype plus freelancing equals prototype freelancing. It's a very creative name, I have to admit. This is the Virginian in Ohio. This is a model railroad that's built by a man, Alan McClellan, who unfortunately passed last year. The Virginian in Ohio, first off, it has a Wikipedia page. I don't know how many model railroads have Wikipedia pages, but this one has one. And it has a history. It has maps that are real maps, and the routes go through real valleys and serve real towns and real mines. The trains that run along it, they have real connections in the real world. It's freelanced, it's made up, but it's rooted in real life. Hey, that sounds like a data science idea. Oh, right, synthetic data. They've been thinking about this for way longer than we have. Synthetic data, when you ultimately get down to it, is playing with trains. It's taking fake things and making up rooted in real life stories about them. So when we go back to what I mentioned at the beginning, Frank Ellison's Delta Lines, his stage for his trains doing real things, his model, it's completely made up. None of these places really existed. They didn't exist on a map. The delta in the Delta Lines was never quite figured out exactly where that was. His trains were doing real things. They were acting like real trains. But the place wasn't very real. To a prototype modeler, on the other hand, they're going to take a real world place and try and fit it inside of their basement. Or they're going to take real data and try and fit it inside of a machine. So this is somebody's model railroad of the Boston and Maine's Hoosick Falls branch. These are real towns. The track plans are based off of the real track plans in these towns. But real railroads didn't have to curve around your boiler and your lawnmower. They didn't have to curve around anything. If you go actually to the Bullock Museum directly across the street from here, Bullock Museum's right over there. I'm a geographer. If I don't know where north is, they kick me out of the geography conferences. If you go over there, you can actually see some route maps of railroads. And the first thing you will notice about them is they are very, very straight because railroads do not like to spend lots of money. They're the startups of the mid-1800s, and they're not going to spend any money for aesthetic curves around things. They want to get from point A to point B with as little spend as possible. So synthetic data, taking real-world things and fitting it into an abstract space. You can even take something that's completely made up and create a history for it. So this is the Fiddletown and Copperopolis. It was a series of cartoons that showed up in train magazines in the 60s, 70s, and 80s. There is no such thing. The real places called Fiddletown and Copperopolis were both ghost towns. There's nothing here. But you can go through all of these cartoons and read the real history of them. That is the essence of where we're going in the future with data science, is making things up, but they could be real. They are self-consistent. They are data that make sense when you compare. If you mixed it with real data, you couldn't tell the difference. Because a lot of our data is really like this these days. This is a plywood Pacific, and to be very honest, this is what most people's model railroads look like. It's a bunch of track. It's down on a table, there's some plywood, there's no scenery. There's trains, they go and they do things for no reasons. This is like having a CSV with a bunch of features, and they're just numbers. That's how we data scientists like to think about the world. We have lat longs. They're just numbers. No, they're real places. I have an identifier for an event. This is a real thing that a real person did. This is something where they bought something. They went somewhere. They did something. It's not just numbers. There's reality. There's a layout, a scenery all surrounding it. It's a continuum. Another word that I keep saying. All the way from obsessive following the details of real life to ab nihilo rejection of those. If we data scientists are going to be continuing in the future, we're going to be the ones deciding where our models live in this continuum. Because let me tell you, we are not in a good place right now. We are way out over our skis. There are a lot of promises out there about things like large language models, and the world at large is noticing them. And you know what? When the world at large notices things that we do and starts imagining futures where that we can't back up, well, that's how we get an AI winter. I really don't want that. And you know what? They're noticing right now. This is the Allegheny Family Survey tool. It's being used right now by governments in Pennsylvania. And even though people have worked really, really hard to make models like this be as uncorrelated as possible with features that they don't want to track, things like gender, race, income, guess what? That's leaked in there. It's real, and it's discriminating against people right now. Courts have ordered them to stop using these models. The things that we make, well, they reflect back in the world on real people. ChatGPT, I asked it to go write me a Python function on what would make a good data science candidate. This is out there. It is live now. This is not an abstract problem. You could do this. That's all I'm going to say about that. So, we're about to go out and break into networking sessions and have lots of conversations. And ultimately, my job with this talk is to prime the pump and jumpstart those conversations. And I am certain that some of you in here, in fact, if I did my job right, everyone in this room should disagree with something in this talk. If you agreed with everything, I have failed. So, the points. Data science is maturing. We're a 60-year-old industry, but we've really kicked it into gear over the last 15 years. And it is no longer the data scientist is select star from data jobs. We are part of an ecosystem, and we need to move beyond being the heroes to being part of a team. And our role, or at least my proposal is our role in that team is to be the managers of the data and the folks who think about how the whole dang thing goes together. Artists, if you will. Our job is to make decisions about what our models are made from. And it's important for us to remember that our models are not reality. They're reflections of reality. And because of that, nothing in them guarantees that the things we do are right. Now, we are, as an industry, very comfortable with things like error bars. The outside world is not. Remember, we are nerds. We need to make our decisions deliberately. We need to actually think about why this data is in systems. What does it really mean? What does it connect to? What do these two pieces of data actually mean together? They can bring information that doesn't exist in the model in each individual data set, and combined, there's now information there that didn't exist before. And finally, if we are the managers of data, we should be editing it. We should be taking a look at what our data, how our data interacts back with the world. Our data should be the change that we want to see in the world. I'm especially worried about this with large language models that are extremely hungry for data and they just feed and feed and feed. You have to pump everything into them to be able to get things to come out. And that means we are feeding all of humanity into them. And quite frankly, a lot of humanity is shit. It's going to be really interesting to see now that we have large language models that write text, because a lot of these things feed on all the text that they get. And that means we're about to get an Ouroboros. The models are going to start training on themselves. And I don't think any of us know what's going to start happening when that starts. And honestly, it's probably started already. Finally, last, and honestly least, model railroading is fun. I am Peter Lenz. I am a data science consultant, and let's have your questions.